College Boards SAT Test 9, Section 3. For the best results on this, you can go ahead and find that test for free on College Board's website. Pause this video and try each problem in Section 3 yourself, and then go ahead and refer to the video for instructions on how to do the questions. So looking at question number 1 here, we're being asked about finding the answer to this system of equations. Just closing something real quick. And one thing you want to look out for when you attempt a question like this is whether you can get the answer without immediately finding x and y. So can you just add the two equations or subtract the two equations to immediately get your answer? And if so, you get a little shortcut, and if not, it's not really a big deal. So if we add straight down just everything in here, we would get 3x plus y equals 12. If we maybe reversed one of the signs, so we'll go ahead and take this one and multiply everything by -1. So that's the idea of subtracting them. So now we would get x minus 3y equals 4. And similarly, if we reverse the sign on the top one, so the idea of subtracting again, but just doing the opposite sign on the top one, not the bottom one. Now, if you add straight down, you'll get x plus 3y equals -4. So the idea of just adding and subtracting them doesn't help, because one of these might have coincidentally worked out to x plus y, which happens frequently and is always worth a try. So now let's go ahead and just literally solve it in the classic way. And one thing that just jumps to mind here is I can see that I've got 2y and -y here. So that makes it seem like the elimination method might be good, because all you need to do on the top is just multiply by 2. So multiply by 2 on the top. So 2x times 2 is 4x, -y times 2 is -2y, and 8 times 2 is 16. And on the bottom, just bring down what we already have. So x plus 2y equals 4. Now the purpose of what we did is to create this situation by multiplying one of them by 2, which we did right here. We multiplied by 2 to every piece of it. We created that elimination situation. So now when you add straight down, you have 5x equals 20 divided by 5, and x equals 4. And then you can easily plug that back into either equation. So I'll take the one that says x plus 2y equals 4. X is 4, so 4 plus 2y equals 4. Take away 4 from both sides, 2y equals 0, and divide by 2, and y equals 0. So we now know that x is 4 and y is 0. So x plus y would be 4 plus 0, so it's 4. So that's the answer number 1, which is going to be B. Now we'll look at number 2. So we need to find something equivalent to this expression. So the nice sort of instinct is to just distribute both of these. So the first one will give you 2x squared minus 2x, and the second one gives you plus 3x squared minus 3x. And now we can see that these two are like terms with one another. And so are these two. So we'll combine the two green ones and the two blue ones. So 5x squared minus 5x takes us to choice A, and number 2 is A. So now going over to number 3. Which of the following statements is true? So the question is asking us about the slope and the y-intercept of each of this situation. So each of them are different possible answers for what is the slope and y-intercept. For when you want the slope and y-intercept, generally speaking, that's another way to say we should be getting y alone. So let's just go ahead and do the work involved in getting y by itself. So you can add 3x to both sides, so that'll make 2y be by itself. So plus 3x minus 4. Divide both sides by 2. Y equals 3 over 2x minus 4 over 2. And now we've got it in a nice y equals mx plus b situation. Just write that a little neater there. 3 over 2 x minus 2. And so we've got it in a y equals mx plus b appearance, and the m is 3 over 2, and the b is negative 2. So the slope is positive, so we want a positive slope, and we do have a negative y-intercept, so these two would have been correct. And of course, the one that has both is choice D for number 3. Going over now to number 4. The front of a roller coaster car is at the bottom of a hill, 15 feet above the ground. The front of the roller coaster rises at 8 feet per second. The thing I'm looking out for here is to make sure that the units are consistent. So we've got feet above the ground rising at feet per second and s seconds. So there's not any kind of conflicting units, which, you know, this is question number 4, so it's toward the beginning, and by nature it'll probably be easier, so it makes sense that there are not conflicting units. So just a nice simple y equals mx plus b linear situation for people who are just joining or just learning this stuff for the first time. A y equals mx plus b basically means you have a starting amount, and then it's either gonna rise or decrease at a nice constant rate, which is your slope. So your y-intercept is where you start, your slope is your rate of how it changes linearly after that. So here it's starting at 15, and it's starting at 15, that's our b, and it's changing at 8 feet per second. So y equals 8x plus 15, and they're not using x and y, they're using h and s. So then the answer is simply going to be on number 4, A. H equals 8s plus 15. Alrighty, so now we're going over from number 4, moving on to question 5. This question can be seen a lot of different ways, but we're going to take it from the perspective of translating slope. And for the higher level students, you're going to want to be experts on the idea of translating slope for some of the harder questions, even though here it's a slightly easier application of it. The idea is that slope is generally your change in y over change in x, which is another way to say y2 minus y1 over x2 minus x1. But we'll turn that into the units of the problem. So the problem is talking about C and H. And what are C and H? That's our change. The triangle means change. Change in the amount of money. So change in the money, which is the charge, over the change in time, which is in hours. So when we talk about slope here, we're talking about the amount of money, how the amount of money changes based on the time. With that background, look how easy this question becomes. One person worked 2 hours longer. How much more did that person charge? Well, the change in money based on the number of hours, we know because the slope, this is a y equals mx plus b, and the slope is the 75 and all of that. So we know the slope is 75. So the money changes at $75 for every hour worked, right? Because it's money over time. And so if one person worked 2 hours longer and it's $75 per hour, then how much more? That's just going to be 75 times 2. So the answer to number 5 is C. And now we're going over to number 6. Okay, on number 6, we're being told that x is 100 degrees. The length of arc ADC is 5 pi. Okay, and generally speaking, the concept involved is the concept of fractions of a circle. And when you have a fraction of a circle, the big idea is, let's say something is 1/3 of a circle, then like a pizza slice that resembles this red pizza slice here if this pizza slice is 1/3 of the circle, then we know that the area of it would be that fraction of pi r squared. So if it were 1/3, it'd be 1/3 of pi r squared. The arc of it, so here we have area, the arc of it is that same fraction of the circumference of a circle, which is 2 pi r. So when we talk about arc, we're talking about a piece of the circumference. And the central angle of it is that same fraction, again, of 360 degrees, because there are 360 degrees in a circle. So that's the idea of fraction of a circle, is that once I know the fraction, that same fraction will apply to the area, the arc, or the angle. So why are they telling us it's 100 degrees? Because it's 100 degrees out of 360 total degrees, and we can divide by 10 to simplify, and divide by 2 more to simplify, and you get 5/18. So we now know that this piece, this pizza slice that has arc ADC on the outside of it, is 5/18 of the circle. So let's go ahead and replace this and say that that also means that we know that the area of it would be 5/18 of the area of the whole circle. The arc, which we already know, we just found out is 5/18 of the circumference of the circle. And the angle of it, which is the 100, is 5/18 of 360, which is the 100. 100 is 5/18 of 360. So now we're looking for the length of arc ABC. Well, first of all, if the blue arc is 5/18 of the circle, the whole circle is 1. So we're kind of thinking to ourselves, 5/18 plus what number equals 1? Let's go ahead and give it a different letter. Let's call it B, since the problem already has an X. So if you take away 5/18 from both sides, you'll have 13/18. So we just figured out that this piece right here is 13/18 of the circle. And that just totally makes sense, because 13/18 plus 5/18 is 18/18. So in other words, it's one whole circle. So when we're being asked for the length of arc ABC, we have to get 13/18 of the circumference. But there's one more really important step, perhaps the most important step on this very difficult problem. This question number 6 should maybe be question 18, because it is very high level and challenge. But if we just stop for a second to tell the story of what they gave us originally, we're actually going to be able to solve for the radius based on that. So the story was that arc ADC is 5/18 of the circumference. It's essentially what they told us. By telling us that X is 100, they told us, they're essentially telling us that the fraction was 100 out of 360, which is 5/18. So we're telling the story, and look how much this is going to help us. Arc ADC has a length of 5 pi that was given to us, is 5/18 of the circumference of the circle, 2 pi r. So we've got 5 pi is 5/18 of 2 pi r. Now we can basically notice that the only variable left is the radius, and we can solve for that. So divide both sides by pi. 5 equals 5/18 of 2r. Maybe simplify the right-hand side, and that'll tell us that 5 is 10/18 of r. Divide by 2. 5 is 5/9 of r. And now to get r by itself, multiply by 9/5. And when you multiply right here, a lot of people wouldn't know that that actually is 9/5. Well, 9/5 times 5 is the same as 9/5 times 5/1. And if you think of it that way, you have a 5 on the top and on the bottom that cancel with each other, and the answer is simply 9. So the right-hand side of this becomes 9, and the radius is now 9. So coming back over to the question that they're asking us, they're asking for the length of arc ABC. ABC, we established a moment ago, was 13/18. So arc ABC is 13/18 of the circumference of a whole circle, because that's what an arc is. It's just a fraction of the circumference. So arc ABC, which is what we're looking for, equals 13/18 times 2 pi r, and r is 9. So simplifying that a little, 13/18 times 18 pi over 1, because 18 pi is the same as 18 pi over 1. But putting it that way allows us to realize that the 18 cancels with the 18, leaving us with 13 pi over 1, which is just 13 pi. And the answer to number 6 is B. So now we're going to number 7. Eight over x equals 160. What is the value of x? So 8 over x equals 160. We don't like having x in the denominator, so we can multiply by x, and it'll cancel here and here. So now we have 8 equals 160x. And to get x by itself, we can divide by 160 on both sides. And so you have x equals 8 over 160. Simplifying a little, that's 4 over 80, divide by 2 again. 2 over 40, divide by 2 again. 1 over 20. And maybe to convert that into decimal form, we could do 1 divided by 20. So how many 20s go into 1? None. How many 20s go into 10? None. How many 20s go into 100? 5. So 1 divided by 20 is 0.05 on this non-calculator section. So the answer to number 7 is D. Now we're going to number 8. Okay, so 8 is telling us that there's no solution, no value of x that satisfies. So I personally think you'd have the most success on this question with the idea of seeing an equation as an intersection, because the converse rule, if the test were really asking you for an intersection of two functions, the rule that we recommend is to get both equations in the y equals format and set those equal to one another. So if you see two equations that are set equal to one another, you can imagine that this was y equals 2ax minus 15, and this is y equals all of this stuff, 3 times x plus 5 plus 5 times x minus 1, so that these are two equations, which would be lines because x is to the first power, and that they had already been set equal to each other to find the intersection. Now, how does this help us, by the way? Because there are 3 ways that two lines can interact with one another on an xy axis. They can hit once, they can hit never, which means they're parallel, or they can hit all the time. Like if you graph one and then graph the other and realize that they're actually the same line, the same, two versions of the same line can be thought of as two separate lines that hit all the time. So we're talking about the idea of one solution, no solutions, and infinite solutions. So here they say no value of x. So they're telling us it's the no solutions. And another way to see that is that these are two lines, line number 1, line number 2, and they're parallel. And so if two lines are parallel to one another, mathematically, that'll tell us that their slopes are equal. And by the way, their y-intercepts have to be different or else they're the same line. But the slopes are equal, more pertinent to this situation. So let's go ahead and simplify this one. 3x plus 15 plus 5x minus 5. 3x plus 5x is 8x. 15 minus 5 is 10. So you have y equals 2ax minus 15 as one line, y equals 8x plus 10 as the other. No solutions means that these are two lines that should be parallel to one another. So their slopes should be the same. So this is a y equals mx plus b right here. Another y equals mx plus b right here. And the slopes are equal to one another. So here your slope is 2a, here your slope is 8, and those slopes are equal. So we can say 2a equals 8. Divide both sides by 2, and a equals 4. And the answer to number 8 is C. Going over to number 9 now. Number 9 is a really easy question that causes confusion for a lot of students, because we're talking about 3 equations and we're talking about the solutions. So we know generally, most of us know that the solution of multiple functions is going to be the intersection point of those functions. But what gets confusing here is that there are 3 lines. So we're not just looking to see where any 2 of them intersect. We're looking to see where all 3 of them intersect. And so how many locations are there where you see blue, green, and purple all hitting one another? And that is only at this point right here. One single point where all 3 of them hit at the same time. And so there's one solution to this equation. And the answer for number 9 is B. Now we're going to number 10. Okay, so here we are talking about parallel structuring. So once again, this can be seen as an intersection. And in this intersection situation, we're seeing that they're saying this is true for all x. So they're kind of telling us that this has infinite solutions. And we were explaining that a moment ago with the 2 linear equations, where infinite solutions for 2 equations means that they're always hitting each other. So in other words, they are the same function as one another. They're twins. And when you're talking about a quadratic, which has x squared, or a cubic, or any of these higher level functions, you're talking about the idea that the coefficients, these guys right here, they basically would be the address. They would tell you how to graph it. And if they're the same as each other, you can't have 2 addresses. So if we can set them up parallel to one another, the corresponding parts are going to be equal. I'll show you what that looks like. But first, let's multiply out this part right here, which looks a little more challenging. The way that I might stay well organized when multiplying that out is by arranging them vertically. And then multiplying just like you were multiplying a number, long multiplication. So right now I'm going to multiply all 3 terms by 3. So if I do that, I get plus 12 minus 3bx and plus 15x squared. So when you do this style of multiplication, notice that I'm writing the sign every time, because that'll be important, because we're going to be adding everything later. Now we can multiply everything by this orange part, the ax. And also write them down in the area where you see the matching x. So 4a times x is 4ax, so I'm going to put it right here. Negative bx times positive ax is negative abx squared. So we'll put it here because it has an x squared. And 5x squared times ax is 5ax cubed. So we've got our columns lined up like that. So now when we write it out, we've got 5ax cubed plus 15x squared minus abx squared plus 4ax minus 3bx plus 12. 1 second for a little water here to clear out my throat. And a very important instinct in this situation, because we're talking about the coefficient for the x cubed, the x squared, the x, and the number, which has essentially x to the 0 power. you want to be grouping them according to those numbers. So you should have the instinct to take something like this and write it the way I'm writing now. So 5ax squared, actually I'll put the parentheses like this, 5ax squared plus 15 minus ab x squared. So the mistake is that this should be x cubed, and I always do that, just so you know. 5ax cubed plus 15 minus abx squared plus 4a minus 3b x plus 12. So what did we do? We said, for instance, both of these guys have an x squared. So let's factor out the x squared, which is right here. And what's left when you factor out the x squared? 15 minus ab. And we did that throughout. So we've got this term with an x cubed, the next one with an x squared, the next one with an x, and the next one with no x. So that's how they're organized. And the question says this was all equal to 20x cubed minus 9x squared minus 2x plus 12, right? So like we said a moment ago, if they are equal to one another, then we're talking about the addresses here, and you can't have two addresses, right? So we can now say that 5a equals 20 and 15 minus ab equals -9. So let's go ahead and start that. So if 5a equals 20, divide by 5 on both sides, and a equals 4. So now we know the solution for a. And 15 minus ab equals -9. Well, we already know that a is 4, so we'll plug that in. Just solving out there, taking away 15 from both sides. Dividing by -4 there. And we figured out that b is 6. So a is 4 and b is 6. ab is now the idea of 4 times 6, which will be 24. And the answer to number 10 is C. Going ahead to number 11 now. Which of the following represents all the possible values of x that satisfy the equation above? So in other words, they're saying solve this. And whenever you have two fractions set equal to one another, that's a proportion. And for a proportion, you should pretty much always cross multiply. So we're just going to go ahead and apply that here. So when we cross multiply, we're saying 2 times x is going to be equal to 2x times x minus 3. So 2 times x equals 2x times x minus 3. Now we can distribute right here. So 2x equals 2x squared minus 6x. We're going to go ahead and subtract the 2x from both sides to get 0 on this side. So minus 2x gives you 0. And minus 2x here gives you -8x. So let's go ahead and now remember that, okay, first of all, this is a quadratic. Quadratics are solved by getting 0 on one side. That's why the instinct was to get 0 there. But quadratics are the ones where, you know, you factor and do different things. Quadratic formula, completing the square, and you need to be an expert on everything I just mentioned. But in particular, when you have a two-term quadratic, you want to use the GCF and follow that with the zero product rule. And I'll show you what I mean by that. So the GCF for 2x squared and -8x, the greatest common factor, they both have a factor of 2 in terms of the number, and they both have a factor of at least x. They both have 1x. One of them has 2 x's, the other one has 1x, so they both have at least 1. So the greatest one they have in common is a single x. And now we're dividing 2x squared and negative 8x by 2x. So 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. And so if you factor out 2x from that other expression, you end up with x minus 4. And so now we have our zero product rule. The zero product rule says if you have two things that multiply out to 0, in this case, the two things are 2x and x minus 4, then you can set each one equal to 0. So 2x equals 0, x minus 4 equals 0. And once again, that's our application of the zero product rule. Dividing both sides by 2, you get 0 here, adding 4 to both sides, and you get 4 here. And the answers are 0 and 4. And before I pick this answer right here, I just want to check because you have denominators. And if you have a 0 in a denominator, then that would be no solution. So I want to take an extra second and make sure that 3 was not one of my answers. And as long as it's not, then we can say for 11 that the answer is B. Moving on now to number 12. Okay, so we're talking about trying to get these two terms here to become one term. So the idea is really kind of a middle school idea here, not to be offensive, because middle school math, I believe, is one of the hardest types of math. But for adding a fraction, for adding fractions, you need the same denominator. And to get that same denominator, you multiply by a factor of the number 1. I'll show you what that means. So we have 1 over 2x plus 1, and I'm going to multiply the 5 by 2x plus 1 over 2x plus 1. So that'll give us 1 over 2x plus 1 plus, and then here, this is really 5 over 1, and then we have the 2x plus 1 over 2x plus 1. And we're distributing the 5 on top. So 5 times 2x is 10x, 5 times 1 is 5. And so you have 1 plus 10x plus 5. And now that you have the same denominator, you can bring them all together. So 1 plus 10x plus 5 over 2x plus 1. And we can combine our like terms here. 1 and 5 are the same as having 6. So 10x plus 6 over 2x plus 1 gives us choice D for number 12. Now we're going over to 13. And for number 13, we're looking to define the function f. And if we look at these answer choices here, the answer choices are all showing off the vertex formula of a parabola. So definitely a formula that's going to be super mandatory. So we have a handful of these things, and we usually use the color yellow to show them, that we believe you can't do your best on the SAT without having firmly memorized. And you'll see why right now the vertex formula is important. Because if the vertex is 3, 1, then that'll become our H and our K. So the vertex is in the format of H, K. And so it'll be y equals a x minus 3 squared plus 1. So now we've got something that looks a lot like this and a lot like this. So we can already get rid of choices B and D. But the question is whether or not we need the number 4 before the parentheses. And the way to do that is to take either of the points that were given to us and plug those in as your x and y, because 2, 5, and 4, 5 are points on the parabola. So therefore, we should be able to plug them into the equation. So let's take the easier one. So y is 5 when x is 2. And we'll keep everything else the same for the rest of the equation. But you see that creates a situation where we can now solve for a. And so we'll go ahead and just go through the steps of solving. So you got 5 equals a times negative 1 squared, and negative 1 squared is positive 1 plus 1 take away 1 from both sides, 4 equals 1a. So 4 equals a, and there is actually a 4 there. So the answer to number 13 is A. Now we're going over to number 14. Fourteen's got these big inequalities here. Not such a big deal for us. But the idea is that if you have y is greater than x plus 2, it's just the line y equals x plus 2. And because it's greater than or equal to, well, first of all, greater than or equal to means solid line, and greater than would mean dotted line. But the factor that it's greater overall means you shade above. So the line y equals x plus 2, that's y equals 1x plus 2. So the slope is 1 or 1 over 1, and the y-intercept is 2. So that's this line right here. It's got a slope of 1 and a y-intercept of 2. And as I said before, we're shading above it because it's greater than or equal to it. So we can already get rid of choice A because we would need to see some shading above it, and there's no shading at all above it. And we can also get rid of choice D because once again, we're looking for shading above that blue line and we're not seeing it. So A and D are out. And then the second line takes a little bit more work. So this was the work we did for the first line. And now looking at the work we're going to do for the second line, the idea is to get it as a y equals mx plus b. So to get y by itself. So we'll leave the 3y where it is and take away 2x from both sides. So 2x plus 3y less than or equal to 6, take away 2x from both sides. Minus 2x plus 6. Why did we say minus 2x plus 6 and not 6 minus 2y? Because we know that we're aiming to get a y equals mx plus b, so the x thing has to kind of come first. Dividing by 3 on both sides, you have y is less than or equal to negative 2 over 3x plus 6 over 3, which is 2. So now for this line, you've got a y-intercept of 2, which both lines have a y-intercept of 2, and a slope of negative 2 over 3. So that means that if we were doing our change in y over change in x, this line would go down 2 and right 3. And so obviously there are only 2 lines and they're all identical. So we already know that this is the line we're talking about. And are we shading above or below that line? We're shading below it because it said less than or equal to. So between choices B and C, we need to see shading below the green line, which we don't see for choice C, but we do see it for choice B. So choice B says we're shading above the blue line, which looks like that. And we're shading below the green line, which looks like that. And what we're looking for is the area that was shaded twice, which is this area right here. And that is shaded in choice B. So B for boy is the answer on number 14. And continuing right along here. Okay, this question right here. What we might want to do here is just simply plug in the answer choices. So the only answer choices we're seeing are -1. So our answers, our possible answers from what they're giving us are -1 and +2, or neither. So either of them, both of them, or neither of them. Now, first of all, for those of you who wanted to say no solution because you have a radical equal to a negative, the idea is that when you have a radical equal to a negative number, a radical or an absolute value, that's no solution. But if you have a radical or an absolute value equal to a negative variable, like x, then we don't want to be so quick to say no solution. Tiny little tedious thing that is kind of being taken advantage of here to cause lots of students who are taking a test like this to get the answer wrong. So since we know that it's not equal to a negative number here, it's equal to a negative variable, so we don't want to be so quick to say no solution, we'll go ahead and plug in -1 and 2. So if x equals -1, you get square root of -1 plus 2 equals -1. square root of 1 equals 1, and that works. The square root of 1 is 1. It's actually plus or minus 1. But in that situation, when you're checking these, you have to know by heart that if I see, when I get the answer, the radical set equal to a negative, which we see in yellow here, then we would have said it didn't work. So let's look at 2 now. If x equals 2, you get a square root of 2 plus 2 equals negative 2. So square root of 4 equals negative 2. And although, yes, the square root of 4 is plus or minus 2, we're trained to see, like we said here, when you have a radical set equal to a negative number, we're trained to say that that is no solution. And why? With that particular issue, I circled no solution when I was saying no solution, but excuse me for that. But in that particular situation, I would rather not even explain it. It's not even worth it for us. If you're a student preparing for the SAT, you're going to want to just simply know that in this situation, we would say that's okay. Sorry, in this situation, we would just say that's okay there. And in this situation, we would say that's not okay. So x equals negative 1 was okay, but x equals 2 was not okay. And there was a solution. So the answer to number 15 is B for boy. Moving right on to number 16 now. What is the volume of a right rectangular prism that has a length of 4, a width of 9, and a height of 10? So you have a formula sheet on the SAT, and it tells you that the volume of a rectangular prism is length times width times height. And we have centimeters times centimeters times centimeters, and we're being asked for cubic centimeters. So we're checking for conflicting units, and there are none. So we just go ahead and say 4 times 9 times 10, which would be 36 times 10, or 360. And the answer to number 16 is 360. Number 17, it's kind of the idea of saving yourself some time. Of course, you could find x and then plug that into 2x plus 1. But if we see the relationship, then we save some time. What's the relationship between 4x plus 2 and 2x plus 1? You need to just divide by 2 to get from here to here. So dividing by 2, you get 2x plus 1 equals 4 divided by 2, which is 2. So dividing both sides by 2, you get 2x plus 1 equals 2. And the answer to number 17 is 2. Now we're going over to 18. Okay. So here they're saying g of x equals f of x plus 6. So let's spend a little time talking about function shifts, otherwise known as translations. If I have y equals x squared and I add to the outside of it, that's as opposed to adding to the inside of something. So I might also add to the inside. But before we do any of that, we need to know that adding to the outside is a vertical shift and it's normal. So vertically, in terms of the y-axis, positive is up and negative is down. And so if I add, it would go up, and if I subtract, it would go down. So if I did like y equals x squared plus 5, we're adding to the outside of it. That means it's a vertical shift and it's normal. So this would just be up 5, because in terms of the y-axis, plus is up and negative is down. Now that we're adding to the inside, that would be a horizontal shift, and it's not normal, it's backwards. So that would look like y equals x plus 5 squared. So by saying the inside, we're talking about the area where x is, and a little parentheses that can be created there. So by virtue of being in the inside, it's a horizontal shift. Normally, in terms of the x-axis, positive is right and negative is left. So this is backwards, so positive is left. So this would actually be left 5. And the same holds true if we're in the f of x notation. So if f of x equals x squared, then this one on the left is just f of x plus 5. And this one on the right would be f of x plus 5. So the same idea of adding to the inside or the outside, just in the f of x notation, as opposed to in just showing the actual function itself, the actual equation itself. So let's apply that to number 18. And we're saying that g of x is defined by taking f of x and doing what? Adding to the outside. So when we add to the outside, it's a vertical shift, it's normal, so plus is up. So this is all a fancy way of saying that f of x is the same as g of x moved up by 6. So let's move it up by 6. 1, 2, 3, 4, 5, 6. And so that takes us to a y value of 6. And so then this other point will also be at y equals 6. And this these points here, these three, they're at y equals 2 when you start. So if you go up from y equals 2, you get to y equals 8. So we're just going to put some points to symbolize y equals 8. And so at a y value of 6, you have the bottom points, and at a y value of 8, you have the top points. And when you graph it, it would look something like that. So what's the maximum value of the function? The maximum value, in other words, the maximum height, is 8. So a little subtlety there in the wording. If I say what is the maximum value, I'm referring to the height. If I say where is the maximum value, where can I find the maximum value, then I'm referring to the x value of it. But here, what is the maximum value? That's y, and our y value for the highest point of it is 8 for number 18. So now we're going over to number 19. Triangle PQR has right angle Q. Okay, so let's just draw a triangle that does that. It's got a right angle called Q. Then the other two angles are P and R. Sine of R equals 4/5. So we're dealing with SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. And for people who are beginners with this, whatever angle we're talking about, in this case, R, that little theta signifies that we're talking from the perspective of angle R. And you always want to start by going right across from that angle. Just go straight out from the angle that you have, and that's the one you call your opposite side. The hypotenuse is always the side of a right triangle across from the right angle. So this is our hypotenuse, side PR. And you've got opposite, hypotenuse, and adjacent. So the one we haven't talked about yet, the one that's left over, we call that our adjacent. So the question says that the sine of angle R is 4/5. So sine is opposite over hypotenuse. The opposite of R over the hypotenuse of R is 4/5. So the opposite is 4, the hypotenuse is 5. Now we're seeing that we have a 3, 4, 5 triangle. So be really familiar with the 3, 4, 5 triangle or any multiple thereof. So for instance, if I take the 3, 4, 5 triangle and multiply everything by 4, then it would be a 12, 16, 20 triangle, which is just an extension of a 3, 4, 5. So this is our 3 on this nice, easier question. And now we're being asked for the tan of angle P. So in the slightly tricky world of trigonometry, if we're shifting our theta to be at P now, it means we're speaking from the perspective of point P. And theta is here. What that does is it means that if I go opposite that, this is now the opposite. Hypotenuse never changes. So by changing the perspective of the angle that we're starting at, the opposite and adjacent end up switching places. Hypotenuse stays the same, but it's still the same triangle. So we still have the 3 here, the 4 here, and the 5 here. So what is the tan of P? Tan right here is opposite over adjacent. So the opposite we already know is 3, and the adjacent is 4. And that is the answer to our question, 3/4. Also known as 0.75, by the way. Okay, going over to number 20 now. So we have a linear function which is called f of x. So f of x, what do we know about it so far? It has a y-intercept of 3 and a slope of -2. because as we go from left to right, let's say point A to B here, we're going down 2 over 1. So negative 2 over 1, slope of negative 2. And this is what they're referring to as f of x. So to be a little fancier, we'll call it f of x instead of y. But then we have g of x, which is perpendicular. So perpendicular slopes are the negative reciprocals of one another. So if our slope is negative 2 over 1, we're going to flip that upside down to 1 over 2 and multiply it by negative 1, so it actually becomes positive. So the slope of line G is 1 over 2. And we're being told that line G passes through 1, 3. So what do we know about line G based on all this? We know a point on it, and we know the slope of it. And the point-slope relationship of a line, which you should absolutely know by heart, is y minus y1 equals m x minus x1. So we're going to use that right now to find the equation of line G, based on the idea that the slope is 1/2 and the point is 1, 3. So the 1 and the 3 we're going to plug in as x1 and y1. So 1 for the x and 3 for the y. And the slope is 1/2, everything else remaining the same. So y minus 3 equals 1/2 x minus 1. So we just filled in the rest of the formula around the x1, the y1, and the slope. Now we're just simplifying this. Well, I mean, we could simplify it into y equals mx plus b because generally we like to see them more that way. So let's go ahead and do it, but it's actually not necessary. It's just kind of a matter of making it look more beautiful. So we distributed the 1/2 to get negative 1/2 here, and we're adding 3. So y equals 1/2 x plus, and this part right here can be thought of as negative 1 over 2 plus 6 over 2, because 3 over 1 is the same as 6 over 2. So we're getting common denominators for that. Maybe write it down, maybe don't. But negative 1 over 2 plus 6 over 2 is positive 5 over 2. So the equation is negative 1/2 x plus 5 over 2. So by the way, that's a y equals mx plus b. So we know the y-intercept. Now, the y-intercept of a function is the moment where x equals 0. And that's what this is saying. This right here is saying take the g function, plug in x equals 0. So if we just plug in x equals 0, this whole part here becomes 0 and y equals 5 over 2. So our y-intercept, the thing that we get when x is 0 for this equation, is 5 over 2. Thanks so much for listening to this video. We hope it helped you out a lot, and stay tuned for more videos. Thanks so much.